Olympian students, solve this question before I do and drop your answer in the comment section and you shall receive a like. You are welcome to this palindromic quartic expression whereby two answers are given. One is real and one is imaginary. Now if you look at this expression now, it's sitting at the center of S square. First step, you shall divide this expression by S square so that you can mirror the pair. Now, S raised to power 4 over S square minus 6S cubed over S square minus 7S square over S square minus 6S over S square plus 1 over S square is equals to 0. When you simplify, the expression becomes S square minus 6S minus 7 minus 6 over S plus 1 over S square is equals to 0. Now group the mirror pair. That's the next thing. S square plus 1 over S square minus 6 into brackets S plus 1 over S plus 7 is equals to 0. Sorry, this is plus, this is plus. Okay, now let's continue. To now represent this expression to be letter y, that is y is equals to S square plus 1 over S square, and at the same time y is equals to S plus 1 over S. And this expression is y square minus 2 by expansion, because this 2 is the center technique of this expression. Now let's move on. Now after being said that, now is to check for the discriminant, which is d is equals to b square minus 4ac. Now we have said that s square plus 1 over s square is y square minus 2. So y square minus 2 minus 6, then y plus 7 is equals to 0. Then when you simplify, you have y square minus 6y plus 5 is equals to 0. Now when you factorize, you have y minus 1 into bracket y minus 5 is equals to 0. So either y is equals to 1 or y is equals to 5. Now to solve for s, we have to have two cases. Case 1 is y is equals to 1. So y is equals to 1, we have y is equals to s plus 1 over s. So 1 is equals to s plus 1 over s. So you multiply this expression by letter s. S in 1, x times 1, s is equals to s square plus 1. So s square minus s plus 1 is equals to 0. Remember, so the discriminant d is equals to b square minus 4ac, because from this expression we have a to be 1, b to be minus 1, and c to also be 1. Now let's write what is our b? Yes, minus 1 square minus 4 times 1 times 1. So now I have 1 minus 4, which is minus 3. Now the discriminant is what? Minus 3. Now which is an imaginary solution, because when you use quadratic equation, s is equals to minus b plus or minus b, s is equals to minus b square root b square minus 4ac over 2a. You have s to be 1 plus or minus I square root 3 over 2. So 1 is real and 1 is imaginary. Now let's move on for case 2. For case 2, that is y is equals to 5. So y is equals to s plus 1 over s. So 5 is equals to s plus 1 over s. So when you multiply through by s, you have 5s is equals to s squared plus 1. So s squared minus 5s plus 1 is equals to 0. Now, the discriminant as well, which is d, is equals to what? B squared minus 4ac. Now, from this expression, a is 1, so we have minus 5 squared minus 4 times 1 times 1. So now have 25 minus 4. So which is what? 21. So now this is a real square root 21, but it's not real. It's a rational number. It's in short form. So now when you use quadratic equation, so the value of s becomes 5 plus or minus square root 21 over 2. Have you done yours? Did you get it right? Now, if yes, drop your answer in the comment section and don't forget to follow Sheldon Maths TV for more Olympiad maths expression like this. Bye bye.